In this video, we are going to simplify radical expressions. So radical expression is when you see the radical symbol like this. All right, what is the square root in simplest form? So what we want to do here is we want to look at perfect squares that are underneath 252. So we could take 252 and we can start breaking it down. So we can start dividing it by some perfect squares that we know. Well, one of the highest perfect squares that we know is 100. It doesn't go into it. And then 9 times 9, 81, doesn't go into it. 8 times 8, 64, no. 7 times 7, 49, and then so on. We just want to see if there's any perfect squares underneath here that I can take out. Well, 36 works, and so I'm going to go ahead and use that. But I do want to mention that I didn't start from like 4 or 3 times 3 is 9, things like that. So I started with the highest number that I can go with, which is 100, because perfect square 100 is a perfect square, 10 times 10. Okay, so anyway, I found a perfect square here, which is 36, because 36 times the 7 equals 252. Look, 36 times 7 gives you 252. And so again, we are simplifying this. 252, square root of 252. So that means that I have square root of 36 times square root of 7. I know what the square root of 36 is. That's 6, right? That's the whole reason I chose perfect squares. 6. And then you have square root of 7. Okay, 6 square root of 7. These 6 square root of 7 is the simplest form. So if you are not familiar with your perfect square, you can always just maybe do x squared and then go to the table, and then you can see all the perfect squares right here. It's 1, 4, 9, 16, 25, 36, 49, 64, and then so on. Those are the numbers I was trying to divide by. That's another way you can find perfect squares. But here is the trick that you can use in Desmos if you want to simplify this, but you just have to remember the steps, okay? So here you're going to do 252, and you're going to divide it by x squared, because that's the perfect square. And then you're going to turn it into a table of values, click on the last button, and just keep pressing enter until you get to like zeros. And then here you go. The numbers are 6 square root of 7. That's my answer, 6 square root of 7. Okay. Well, that's one way you can do it. I mean, actually I showed you like 2 different ways you can do it. Yeah, so let me go to the next one. So I'm trying to simplify 1 square root of 180. I know I have a number on the outside, a number on the inside. So that is, I'm just going to do it the easy way, 180 divided by x squared. It's just that students, you might forget to put the square because you're taking the square root. Don't forget that. Turn it into a table, go towards there, and then just keep pressing enter until you get to zeros, or maybe right there. Yep. I'm going to scroll up a little bit and see the first 2 numbers that you come across from the bottom up. So you know that's the most simplified version, 6 square root of 5. Okay, let me do it the other way if you don't think you can remember the steps. So here, to simplify 180, you're trying to see what goes into 180. You can try to guess some numbers, but since you have Desmos nicely available, just, try to look for some perfect squares. I can start with 100. That doesn't go into it. And then that's 9 times 9, which is 81. Nope. 8 times 8, which is 64. 7 times 7, 49. 6 times 6, 36. And there you go. Well, 36 works. So 180 is the same as 36 times 5. Or I should say square root of 180 is the same thing as square root of 36 times square root of 5. And we know the square root of 36 is 6, and then you bring down the square root of 5. Okay? With this one, I already have a number on the outside, but it looks like I need to go ahead and simplify this. So I keep the 2 on the outside, and I'm going to simplify square root of 48. Okay, well, let's see. So 48, I know 100 is way too big, something that's like not so big. Let's see, 30, something lower than 48. 20, well, I guess 36, we can try 36 because that's lower. The next number is 7 times 7, which is 49. That 49 is bigger than 40, so that's not going to work. 36 doesn't work. 25, no. 4 times 4 is 16. There you go. 16 times 3. So this is going to be square root of 16 times square root of 3. Bring down the 2. And then I can go ahead and simplify square root of 16 to say square root of 16 is 4, and then 3. And you can go ahead and multiply the 2 times the 4, which is 8, square root of 3. Okay, please do not get these ones wrong on the SOL. All right, now we have some with variables. We have square root of 64 times all of this. So let me go ahead and break this down. I can go ahead and break down this radical by saying square root of 64 times square root of x10 times square root of y16. Okay, all right, so square root of 64, that's easy, right? Because square root of 64 is 8. That is a perfect square. Like square root of 64 is 8. If it wasn't, then I'd have to do all of this, but since it is, that's done. It comes out of the radical. Okay, make sure you know that it comes out of the radical, because square root of 64 is 8. Square root of 64 is not equal to square root of 8. Anyway, that's that. So square root of 10 x to the 10th power. So what this basically does is you're trying to take out as many perfect squares in here. So when we look at variables, a perfect square would look like this. Let me maybe turn in a different color. So x squared is a perfect square because square root of x squared is x, because x times x gives you x squared. So just remember, square root of x squared is a perfect square. It just gives me my x back. I want to see how many x squares do I have underneath here. Well, if I do 5 of the x squares, okay, 5 of the x squares, I would get 10 of them here. So basically what I have here is, and then each of these gets square rooted, right? And then square root of x squared is just x. This is also x. This is another x, another x, another x. Anyway, there are 5 x's underneath this perfect square, okay? So then you would say, don't worry, I will show you a much easier way to do it, but for now I have to show you the, like, what does this all mean? So there's x to the 5. And then how many perfect y's do I have in here? It would be 8 of them, right? Because basically for every 2 of them, one of them was coming out. So there's 8 2's in here. So this is going to be y to the 8th power. Okay, because I'm not going to write it out because it's too many. Because y squared, y squared, y squared. I want to see how many y squares that make up 16. Well, there's going to be 8 of them. Okay. So that's the whole idea behind taking out the squares. Anyway, this is a lot, right? That's the lesson of it. Now, sorry if we wrote all this out. I don't really need all that. Let me show you a much easier way to do this. Okay, so I'm still going to break it down like I did. So square root of 64, my bad, x to the 10th power then you have square root of y to the 16. Now, square root of 64 is 8. That's the easy part. What you can do here is, since this is an even number, I can just go ahead and just divide that out by 2. Divide that out by 2. So then that would mean that I have x to the, what do you call this? 10 divided by 2 is 5. And then y to the 16 divided by 2 is 8. And that's my answer right there. I don't know why I have two different colors, but that's my answer right there. Okay? And then here, it gets a little bit more complicated because first of all, square root of 24 is not a perfect square, so I'm going to have to first simplify that, and then I'm going to simplify this. Let me go ahead and break this down. So you have here square root of 24. Then you have here square root of x to the 6, which is going to be x to the 3rd. You see that already. And then you have here square root of y to the 25. Well, that's not an even number, right? Anyway, square root of 24. Let me just go ahead and do that in decimal. So let me remember my steps. 24 divided by x squared. Turn it into a table. Press on the last button, enter, enter, enter. So it looks like this simplifies down to 2 square root of 6. So this one is 2 square root of 6. That part is done. All right. Square root of x to the 6, because I said that I can just do 6 divided by 2. There's a 2 here. Okay, there's a little hidden 2 here. You don't see it, but it's there. So that's 6 divided by 2, which is x to the 3rd power. 6 divided by 2 is x to the 3rd power. And then this one, I know that 25 doesn't divide out evenly, right? So if I did 25 divided by 2, I get a decimal. So what I have to do here is I have to take out only the even parts, and then the rest of it stays underneath. There's only one y that'll stay underneath. So this is what it's going to look like. You can say that this is going to be square root of y to the 24, since I can go ahead and divide that by 2, times square root of y. Okay, so 24 plus 1 is 25. This one I can go ahead and simplify, right? Because that would just be y to the 12th power, because 24 divided by 2 is 12. And then I'm going to go ahead and bring everything else down. X cubed comes down. 2 square root of 6 comes down. Everything is being multiplied. And then look, square root of y comes down. So the things on the outside get to be together. So that's 2 x cubed y 12. And then underneath my radical, I have 6y. And that's that. Okay. Is there an easier way to do this? Yes, I just showed it to you. Okay. Anyway, that's what that is. Let me go to the next page. All right, now we have here cube roots. So we are looking for perfect cubes in here. Well, what are some perfect cubes? Let me see. X to the power of 3. Let me turn it into a table. And then here are my cubes. 1 is a perfect cube. Cube root of 1 is 1. 8 is a perfect cube. Cube root of 8 is 2. 27. Cube root of 27 is 3. And then so this column right here are my perfect cubes. So what I'm trying to do is I'm trying to take 432 and I'm trying to divide out some perfect cubes. Let me see what 8 cubed is. So 512 is too big. I'm going to have to start with 343, which I think it's still too big. 343, that doesn't go. 216, 2, that works. What that means is cube root of 432 is the same thing as cube root of 216 times cube root of 2. All right, cube root of 216 is going to be 6. I can show you. If you want to know where cube roots are, it's down here in function. I'll scroll down right here. So cube root of 216 is 6. That's a perfect cube. And then so cube root is, I just said, I don't know how many times I'll say it. So cube root of 216 is 6. And then cube root of 2, you just leave it like that. So that's my answer for that. Okay, 6 cube root of 2. Which is equivalent to cube root of 16? Okay, well again, I'm going to go ahead and look at 16. I'm going to divide it out by some cube roots. Perfect cubes, I should say. Well, for 16, I have to start with 8 because 27 is too big. 8, well, I know 8 goes into it, right? Is 2. So what that means is cube root of 16 is the same thing as cube root of 8 times cube root of 2. Cube root of 8 is 2, right? Cube root of 8 is 2. So 2 cube root of 2 is my answer. So I have a 4 on the outside. I already simplified cube root of 16 in my previous problem. So I have 4 times cube root of 16. I just simplified it down here. So that's 2 cube root of 2. So I have to multiply the numbers on the outside. 4 times 2 is 8 cube root of 2. All right, here's another one, 43. Well, I mean, that's a pretty big number. So let me go ahead and explore this in Desmos. So let me go ahead and keep finding my cube roots and see what number I can divide by. All right, so it looks like I can go ahead and divide this number 3, 4, 5, 6. Notice I didn't put the comma. Okay, that doesn't work. You'll get an error. Okay. 2, 3, 4, 5, 6 divided by, now I need to start dividing out some cube roots out of here. So 4,096 is too big. I mean, if you want, you can start. I mean, it's going to be way too big. So you just keep exploring. I like to just do it in order just so that I don't miss anything in here. So 2197, that's not going to work. 1728. Look at that. 1728 times 2. 1728 times 2 would give me 3456. So let me just write it out here. So cube root of 3456 is the same thing as cube root of 17,028, not 17,028, I'm just making up numbers now, 1,728 times cube root of 2. So what is the cube root of 1728? Well, it's 12, because 12 times 12 times 12 is 1728. So that's just 12. And then you have cube root of 2. And that's that. All right, for which value of x does a cube root of x simplify to 5 cube root of 7? So basically, just simplify all of them and see which one simplifies down to this. And then we'll see what x has to be, okay? So the first one is asking you to do cube root of 35, okay? Because x, the numbers are values for x, okay? So this is kind of a weird question, weirdly written question, but that's what it's asking for, cube root of 245. This one would be cube root of 875. And then this one would be cube root of 1715. 1715. Okay. All right, ready, guys? So I can go ahead and erase all these big numbers. I know I'm going to start with the biggest one. I'll start with answer choice D. 1728 will be too big. So look, 1715 divided by 1331, that's too big. 1000 is definitely not going to go into it. 729 looks a little promising. Nope. 512. New. 343. Yes, that works. So this is the same thing as cube root of 343. That's a cube root. Times cube root of 5. Now, the cube root of 343 is what? 7, right? So this is just 7 cube root of 5. We are trying to look for this answer, 5 cube root of 7. This one gave me 7 cube root of 5. Close enough. All right, I'm going to do it the easier way here. So if you remember the steps, 245 divided by, instead of putting x cubed, because I'm doing x cube roots, I'm going to have to put x cubed. Sorry, instead of putting x squared, I have to put x cubed. Okay? And I'm going to do boop, boop. And then you do. You don't have to make those sounds like I'm doing. Well, look, I don't have anything except for 1, right? 1 times 243, which means that this is, I cannot simplify this. Let me try 875. Honestly, this is I predict you guys getting a question like this on the SOL. Boop, boop. There it is, 5 cube root of 7. So this is going to be 5, the number on the outside, and then cube root of 7. So this method, what it does is it does the previous method where I was manually putting the numbers in, but this method in the decimals just, does it for you. So if you have any questions on how to get good at this skill, please let me know. I will walk you through it in class, okay? Anyway, the answer is B, because that's the one I was 5 cube root of 7. 5 cube root of 7 is exactly what I am looking for. All right, last one, complete. So same thing, I'm just doing cube root of 324. So I'm going to do 324 divided by x cubed this time. Boop, boop. Just keep pressing enter, and then there you go. 3 is a number on the outside. Okay, cube root of 12 is a number on the inside. All right, you guys. Thanks for watching.